Let the fun commence. We are going to start with this Predicta. This is one of mine, and it's in the worst condition, I believe, of any of the ones we're going to be working on. That's why I want to start with this one. The cabinet needs to get stripped, de-rusted, repainted. We're not doing that now. What we're going to do is we're going to get this process streamlined. We're going to get this one working, take notes, apply it to the rest of the sets, hopefully. And I've been thinking about how to work up a strategy to work on all of these. We have to pull the chassis on all the sets, that's for sure. But once I get one of them working, we can detach the head unit and plug that into the chassis on the other sets, leaving the rest of the cabinet together. Likewise, we can use a tuner from a restored set. So once we get one good set working, or one set working well, we will swap in parts of the other sets we're going to be working on in and out to make sure everything is working properly. In other words, we can use an already restored tuner and a good CRT with the chassis we're currently working on, and once we put that chassis back in the set, we can make sure the tuner and the picture tube are working right. Alright, so let's get to it. I already did check out this set back when I got it. It was obviously damaged in shipping. This collar got bent. I could possibly try to bend it back, although I got a lead on a replacement, so I'm going to hold off on that. It's cast aluminum. As someone commented when I posted a photo, he was surprised that it didn't break, and I am too. Yeah, aluminum's soft, but this is pretty thick. I would have thought it had some stress cracks in it. I also noticed the volume and contrast knobs are missing. I thought I had one or both when I got it. I got to go back and watch the revisit the video when I got this set a while ago. I may have taken them off and put them away for safekeeping. This set was filthy inside when I got it. I already cleaned off most of the dust bunnies, and it is all original, which is another reason why I want to start working on this set. Alright, so we need to get the chassis out. To do that, there are some bolts below. I believe they are 5/16, whereas the rest of the screws are 1/4 inch, so I need to get a different tool. I went and reviewed the footage from when I got this set, and yes, I do have the knobs. They were around here somewhere, and we did try powering it up. We did not get any signs of life out of the picture tube, but I did test it, and it is good. The tube's lit up, but we didn't get any high voltage produced. So, okay. We know the power transformer filament windings are okay. We know the picture tube is okay. Not much else beyond that. Right now I'm going to pull the main chassis out. A bunch of 5/16 screws down below. I'm hanging it over the edge of the workbench so I can get to it. One of the feet is missing, which is a common issue. So that's one reason I have masonite on my workbench surface right now, is when I slide this, because the foot's gone, I just gouge that up. That protected my plywood down below. That's exactly why I put it on there. Now I need to keep all these sets straight. So I'm going to have a separate container for each one, for all the hardware. Everything's going to be labeled. I'll put sticky post-its on everything as needed. Do not want to mix anything up. This thing's pretty rusty inside too. What I figure I'll do at some point is I'll try to put the entire cabinet into a electrolysis bath, which should remove both the rust. Well, I know it'll remove the rust, but hopefully remove the paint too. Alright, I think that's it. Whoa. strong by the time I'm done with all these sets. Stronger anyways. Alright. This can be a little tricky. If you're going to try doing this, be patient. There are a bunch of wires, and there are some cable ties here and there. In some places there's bits of metal that are wrapped around the leads. There are connectors. I've already pulled them out from when I earlier pulled the chassis, but normally the CRT pins would plug in here and the yoke would plug in here. I put this back in. I didn't bother to reconnect though because I knew I'd be pulling it back out. Alright, hung up on something. I think there's a wire pinched up there. Oh, there we go. So we'll have it on the left side because that's where the power transformer is. So some control harnesses. I already pulled the one. Oh, that's where the power switch wasn't there. It's because I already disconnected this. Power, contrast, volume. You're going to need to disconnect that from the front of the cabinet. And there's a control cluster in the upper left as well. That's what these wires are going to. That's the last thing we have to deal with. A 1/4 inch sheet metal screws. The whole assembly comes out. Go, and I've already disconnected the tuner, so that's it. We are good. We are good. Good idea to take tons of reference photos so you know how to put everything back together. And by that I don't just mean putting the screws back in, I mean putting all the leads back. The lead dress can be important on this stuff to minimize noise and maximize picture quality, etc. Right, there we are. So yeah, it is corroded. I've had one like this before. You can take this box off, bunch of 1/4 inch screws. You can take this, comes apart in 2 pieces. I can put this whole thing on Evapo Rust and get rid of that. It'll look beautiful. Likewise, the shield on the IF, although it's not too bad, but you can untwist a few tabs down below, and that whole thing will come out. But, for those of you who haven't seen the insides of a 17-inch Predicta, here it is. I will briefly give you a tour. Power transformer, modern-ish silicon rectifiers, forming a voltage doubler for the power supply. Although it has a power transformer, they still use a voltage doubler for whatever reason. That's the design they used rather than like a full wave rectifier. Thus there is AC on the outside of one of the electrolytic cans. That's why this is in cardboard and insulated, because there is AC. That can does not get grounded. There's another filter cap. This is the IF intermediate frequency amplifier stuff. The tuner input would plug into this, so your IF frequency would come out of the tuner and be amplified through that. The output of that goes into the main board. Another big electrolytic over here. Vertical output transformers, big thing here. That's a filter choke for the B+. This is what makes the high voltage. The high voltage CRT lead I've already disconnected, but it normally would go through that whole horizontal output tube. Powers this box, so we have a lead going in there. That is the damper, which also works in conjunction with this box and the yoke, so all this stuff is grouped together. And everything else is on here. So this does this sound amplification, the video detection and amplification, the horizontal and vertical sweep synchronizing circuits, all on here. Switch on the back, local distance, that controls how much gain you've got on your front end. Now we got our control clusters, so brightness, vertical and horizontal hold. And these 3 controls, and this cluster, push on, push off power, rotated for volume, and the one on the rear is contrast. There's also a vertical linearity wire wound pot here that is a common source of trouble. It looks like this is the original I've got some ideas on how to deal with that. I know it's damaged on some of the others. And I do believe, yes, this is a width control. Alright, so what are we going to do? This is how I do it. I'm not suggesting, if any of you are watching this or contemplating working on a Predicta, I'm not suggesting you do what I'm about to do. What am I about to do? I'm not going to troubleshoot this set. I'm going to tear it apart and rebuild it. So I don't know what term you want to use for that, whether it's a restoration, a repair, an overhaul, but that's what I'm going to do. Why? I've gained a lot of experience restoring these. I've worked on over a dozen. And I've got good service info. I've got the original Philco little pocket guide. It shows it how all these wires hook up. And I've got other examples to compare it to. And like I said, I've done it, so I know how to take it apart. I know how to put it back together. It gives me a lot of confidence that I can just get in there and get it done. But not, trust me, the first time I worked on one of these sets, I'll tell you what, the first time I worked on one of these, I stopped. I poked around a little bit, I changed some tubes and stuff, and I just stopped, because it was, I think, the first vintage TV I ever tried to restore, and I knew that I was way over my head. And I didn't get back to it for a few years while I worked on other sets. That's why, and part of the reason, as I said before, that I think these get a bad reputation. Yes, there are some, these are different to work on, the way things are laid out. There are some things that are a little bit trickier to work on. But I see a lot of guys who've never worked on a TV before, and this is their first one they try, and they get frustrated. So did I. I stopped working on it. I bought into that, like, oh yeah, these are a pain in the butt. I mean, maybe I'll never get it to work. Then I learned more. And I got back to it, and it made more sense to me. Alright, so what are we going to do? We're going to take this board out. To do that, you may have heard about all the dreaded wires. Yes, the connections on this are created by wire wrap. There are posts on the circuit board, and there's wires wrapped around it. They're not the only ones who did that. GE did that. I believe RCA did too. They weren't the only ones who used circuit boards. Anyways, so we need to unwrap all these wires. Again, because I've worked on these a lot before, I'm not going to label them. I'm not going to worry about it. I'm just going to take them off. Once you've done a few, the wires kind of stay in place after you unwrap them. Don't go and bending and pull the wires out. Just kind of leave them in place, and they'll kind of float there. When you go to put the board back in, they go kind of back in place. Take reference photos. Notice some of these wires, I got an orange wire here, a blue wire here. They'll stand out. That's another interesting difference. Some of these sets have a mix of cloth covered and plastic covered wire, as does this, whereas I think others have more plastic coated wire. I don't know if this means it's earlier or not. I'm not sure. Cloth ones are a little bit more of a drag to work on because they're a little bit stiffer, and each wire does have different color stripes on it, but they're a little hard to see, whereas the plastic coated wires, yellow, it just jumps out at you. It's easier to see the difference. How to get them off? I'm going to use needle nose pliers. Yes, there are dedicated wire unwrapping tools. I don't have one. Also, I've noticed, or not noticed, the way I do it is I don't unwrap the whole thing with big dramatic motions. Just kind of tease it a little bit to loosen it up, and then you can usually pull it off while leaving it still more or less coiled. And then when you go to put it back on, you can kind of push it down and just cinch it up a little bit, and you're done. You don't have to do anything elaborate. Yes, it's been discussed, hey, why don't we put push-on connectors on the ends of the wires? Not worth the effort. You're also going to be altering things, because right now these wires come in at the bottom and then they wrap around upwards. If you put a push-on connector, then the wire is going to be coming in from the top and going down. And all these wires are going to be going like this instead of coming in like this. And you'll spend more time doing that than it would have taken you to just unwrap it and wrap it back on. Which leads to the other thing about what am I going to do with this. I said I'm not going to troubleshoot. I'm not going to test any of these parts. I'm just going to replace everything that's likely to be bad. The stuff I won't replace, like the coils, I'll check for continuity. And then I've never found one that's bad, so I'm not really concerned about that. I will check the traces to make sure they're not broken. I will check the tube sockets to see that they have that there aren't any cracks in those. I'm just going to put it back in, and fingers crossed the set will come to life. There is another circuit board under here, the IF. There are no paper caps on this board. They may or may not go into it. It's ceramic caps. The only thing I might do in this is replace some resistors. My little parts bag does have all these resistors in it. It's not too hard to get the board out, and this is where you would do your alignment. These screws sticking up here, don't mess with those. And there's some powdered iron cores down in here. If we needed to do an alignment, this is where you would do it. I've never really needed to do it. They call these circuits, I think they call them perma circuits, because supposedly they would never need to be serviced. That does seem to be pretty true for the IF box. I've never really had to do anything major to any IF box in any of these sets, and this is common to, I think, all the Predictas. The 17-inch, 21-inch, they all use the same IF, and they use these same boards basically in other sets, console sets that predate the Predictas, especially this. So that's, I think they ironed out all the kinks and it works pretty well. Now, I won't go into this much detail on every set by any means, but I am on this one to give you some idea of what's to come, and two, to refresh my memory, because I haven't worked on one of these in a couple of years. I'm taking some reference photos right now, and I will create a separate folder on my computer for each set. Alright, let's get to it. This will be my primary tools here. These came from that estate recently. They're much nicer than the needle nose that I have been using. Alright, let's start on this guy. Oh, by the way, there are also labels on the board, like this says vertical hold on it. Our vertical hold goes to the top one, and below it, that goes to linearity control. Sometimes it's a little hard to find the little end of the wire. There we go. And then we just do a little of that. Tug on it. Well, this one's a little bit tricky because there are two wires. There's two tiers of them. So there's another one down below we need to get out to. Unwrapped it a little more than I intended, but do what you gotta do. There we go. Sometimes the wires will break off. I've never had one break off all the way out of the insulation. When you go to put it back on, if there's not much left, you strip some more back or just solder onto the stake. Hold it in place better. Have I needed to take out a board again? Very, very rarely. I don't think I've ever. I mean, on a 21-inch set, yeah, and that's because I screwed up replicating one of these couplates. But now, there's a vendor that sells replicas, so we should be good with that. Now, once these are all unwrapped, so I said these kind of just stay in the general area when I got to put it back in. You know, as you do them, they kind of just starts making more and more sense. There are also some of these stakes are bent over and soldered to little forks on the chassis. We will need to unsolder those to get this board out. And there we go. Piece of cake. One final thing I did that helped to get it out was I took the one nut holding the vertical output transformer in place and then bent it out of the way. Well, I got this out. I'll clean that up. A lot of dust and dirt in there. Alright, now we can put everything to the side and just focus on this, which looks to be in pretty darn good shape. I've seen a lot of folks look at the underside and they see these darkened areas. Oh man, that looks really charred. Looks like it all got all burnt up. Nah, that's no big deal. It's just time and a little bit of heat. These don't burst into flames. I've been seeing that rumor going around again lately. Nor did the Predicta bankrupt Philco. The presentation before me at the early television foundation convention this year is going to be on that very topic. How do I know that? Well, for one, I found somebody's master thesis from the mid-70s was written just on that, the finances and the downfall of Philco. And he goes into detail about their crazy amount of spending on R&D. They got into semiconductors, computers, all kinds of appliances, crazy devices like the ionitron, I think it's called, a negative ion generator to make you feel better, make the air cleaner. Their crazy refrigerator with a big V on the front that had magnetic hinges and you can open it on either side. And yeah, they've spent a ton on R&D on these too. And yes, they did have some issues. Yes, they did have recalls. I'm not saying they didn't. But the entire company was not making Predictas. That was a small part of the entire company. They're also a defense contractor. Anyways. So yes, this is what the heart of a 17-inch Predicta looks like. I'll give you a real brief tour of this now. This is the horizontal stuff over here. Horizontal oscillator. This couplate helps the horizontal oscillator do its thing, as does this couplate. What is a couplate? It's sort of like an early integrated circuit. Here's a better shot of one of them. So there are 4 parts in this. They're tubular resistors and tubular ceramic capacitors. Generally pretty reliable, but the resistors are carbon-based and they do drift off in value just like carbon comp resistors. The capacitors are generally pretty stable, but replicas are readily available. These are tough to test because sometimes the internal connections make it impossible. Like you might have a resistor in parallel with a capacitor, meaning you can't check the capacitor for leakage. This is another type, kind of a flat assembly. This is more like a hybrid, kind of thick film technology. That's the vertical integrator. Yeah, so back to our tour. So this is the horizontal stuff. That's a ringing transformer or flywheel transformer. With a few different names that helps it to keep oscillating, sort of like a tuning fork. And that is a dual selenium rectifier. We'll be replacing that. That is part of the horizontal discriminator. It helps it lock onto the incoming signal. Let's see. Video amplifier. So this takes the signal from the IF board, which I believe has a detector on it as well. So we do think we just have the video, composite video coming into this board. This amplifies it. Believe this is a sync separator, which separates the sync signal out from the video signal. And this is a vertical oscillator output tube over here. That's why they have the vertical output transformer right next to it. And then we have sound over here. And that's our audio output tube. I believe that's the audio preamp tube or discriminator. That's about it. There's a few more controls on the back here. These two, I don't remember exactly what those are. Not stuff you need to adjust very often. I know it's not linearity. I have to look that up. There might be sort of a coarse range for the horizontal hold. I guess I can look on the back of this. Hang on. I should know this. Oh, height. And one of them isn't labeled. I think it's height and maybe coarse horizontal hold. That's about it. These black things are paper caps inside of plastic tubing. They're just as likely to go bad as these ones that are all paper. Likewise, that's a paper cap inside of a ceramic tube. They also go bad. Just paper cap, paper cap. A couple mica caps. I'm not going to replace those. Those basically don't go bad. Not that type. All these guys are resistors. All these tubular looking things, the green ones as well, are just a different manufacturer, but they're same as the black and brown ones. These vertical looking things, those are coils, actually. Give you a good shot at that. So the coil is wound sort of vertically inside this plastic housing. And these are just inductors. They're not transformers, they're just, like this is a 220 microhenry inductor. These are transformers. I believe this is the sound discriminator for the ratio detector. If we need to touch up the sound, that would be where we would go. Possibly this one. But I don't think I've ever had to adjust those ever. These guys are a bunch of ceramic caps. I don't bother replacing those. They extremely reliable devices. I'm not concerned about that. So we're replacing all of these tubular paper caps, all the cup plates, all the resistors, and we're going to examine all the tube sockets. I just pulled out something that will be very useful in this adventure, which is the last 17-inch set I restored 2 years ago. When we are done, this board will look like this board. And notice there are 1, 2, 3, 4 electrolytic caps mounted on it. And that can is gone. And that can is gone. And that can is gone. That frees up space, makes it much easier to work on, especially down in here with that big electrolytic gone. I was also kind of starting to at least crudely keep track of how much time I'm investing in this. And in spite of what I said, it definitely took me longer than I would like to get all those wires unwrapped. So I'm going to investigate building or acquiring a tool to unwrap these connections. Now it's a little tricky because these are not square, these are rectangular. I have had wire wrap tools in the past for integrated circuits, but they worked on smaller square posts. And I don't think it should be too hard to build one. And I may very well be able to buy one, because I remember seeing stakes similar to this in backplanes used in telephony equipment or something like that. I'm sure they're floating around out there. Alright, I think we are all set to dive into this. So I can constantly refer back and forth to this board while I work on this, and then this will become my reference for the others, and I'm going to put this back out of the way. Yeah, that is the plan. I'm almost done, but not quite. The reason I pause now is I want to discuss a situation that I knew might arise, and somebody asked me about. Another restorer asked me about this when he saw that I was going to be restoring a bunch of Predictas, and that is, well, there were 7 different production runs of this 10L43 chassis, and what he asked me was, are you going to get them all up to the last revision and go through all the changes? And I said, well, I don't really know. Well, this is a different revision than the reference that I've been using, it turns out. And I kind of knew that right away when I looked at it, because there's an area here where there were no parts installed. And what really got me to pause here is on the chassis I had previously restored, 2 resistors side by side, 22K. Now on this chassis it was a 22K and this, which I couldn't quite read. It looked a little discolored. It kind of looked like 10K, but I wasn't sure. And when I measured it, it was nearly 20K. Well, luckily I have a printout of this, which is the be-all, end-all. It's the Philco factory service info for the 10L, 41, 42, 43, including at the back all the production run changes. Now, one of the reasons I was a little vague about whether or not I would include them all is I'd seen this before, and I knew that some of them, for example, down here it says, to facilitate production, they removed one capacitor. Not to improve performance, not because they discovered a design flaw, but to facilitate production. So what does that mean? They could make it faster, cheaper. They had trouble sourcing this part. I would just as soon leave it in if I saw it, or just replace it and move on. But in this case, this particular resistor, it's the last item on here. They changed it from 22K to 10K. They say to improve sound and sensitivity and facilitate production. How does changing the value of a resistor facilitate production? Unless they couldn't source that part. I don't get that. So what am I going to do? I'll replace it with the value I found. Which means my little parts kit I made isn't right because I made it for the earlier revision. And so be it's 10K resistor. They're easy enough to come by. And we'll see how it goes with the other chassis. All the changes are minor. And a lot of them have to do with just subtle things that I think I'm pretty confident that when you're feeding it with a strong, directly wired signal source, they're not going to be an issue at all when it comes to things like improving fringe response or performance or gain or whatever. It's when you're feeding it a strong signal, it just doesn't really matter. Now, for those of you questioning the wisdom of just bulk replacing all the resistors, let's check some. Here's a random assortment of resistors that popped out of this set. Let's just spot check a few. This should be 6.8K, 6800 ohms. 7.4. It's drifted high. At the fringe of being within 10%. That's not uncommon. These are carbon comp resistors. They drift up with age. This should be 1.8K, also drifted high. Here's that 10K I mentioned earlier. 19K, definitely needed to get replaced. 100K, 14% high, it should be 10%, slightly out of spec. 4.3K should be 5%, so it should be pretty close to 4.3K. And it is. That would have been acceptable. Let's keep going. Should be 270 ohms, 5%. Ooh, no, that is not within 5%. Alright, should be 100K, no tolerance, so 20%. And it is, it's low. That's unusually drift high, but that's within tolerance. It should be 100 ohms. Ooh. No, maybe 10K. Yeah, I think 10K. It's measuring 29K. Obviously way out of spec. Almost 30K. Should be 180K. It's 6 meg. That is complete crap. I noted that earlier, so that's one reason I wanted to do this. I knew there were some really bad ones in here. 1.5 meg. It's pretty close. That's why I don't bother going through and checking all of them. About 80% are bad to some degree, some far worse than others. I don't want to go through and check them all by one. Sometimes you have to lift up one leg because they're wired in parallel with some other parts that might affect your reading. Plus, all my replacement resistors, generally speaking, are double the wattage. The half watts are replaced with 1 watt, 1 watt with 2 watt, 2 watt with 3 watt. I figured it would be more reliable. Now, when it comes to these guys, there are resistors and capacitors in here. sometimes you can check them, sometimes you can't. It depends how it's wired up inside. It might be interconnected such that you can't isolate one component by going through the pins and testing it. But typically, these are carbon-based resistors, and they do drift in value as well. The capacitors rather, are quite stable. So it's not unusual for these to still work. But again, it's tough to test them. I just as soon, now that there's readily available reproductions, just do it. We shall see soon enough if my strategy pays off. Back to the service info for a moment. A lot of guys get a copy of the SAMs. You can download it for free from the Early Television Foundation, or get a copy off of eBay or some such. This is really, really good to have too. And this little guy can also be pretty handy. It has the entire 1960s lineup in it, including the portable Safari transistor TV. Now, you don't get all the detailed info. For example, there's no parts list. But what you do get is a full schematic and a chassis component layout and a component locator. It's very handy when it comes to wiring the set up, double checking things against a schematic. Otherwise, this guy is very comprehensive. Full parts list, like I said, mentioned production changes, schematic, and one really, really nice thing is this. Critical lead dress information. This will tell you, so all those wires we had to deal with when we took the chassis out and had to snake around, and some of them were hooked up to various things like wrapped around this or various tie points. This tells you how everything should be hooked back up to minimize noise and interference and any issues. Very, very good page to follow.